in this question, we want to look at the money multiplier, where we're assuming that the economy has a central bank along with the banking sector that collects deposits. So before we proceed, there are certain things that we should keep in the back of our mind for this problem, right? So let's just go with that. Things to keep in the back of your mind for this problem. So here the money multiplier is given as follows. Multiplier is equal to 1 by c plus theta 1 minus c. So this is how in the text the money multiplier is defined, where c is the fraction of total money demand, fraction of total money demand in the held as currency. So here C tells us how much of your money demand do you want to keep in the form of currency, because when you do have a banking system, so you don't have to just choose how much of your wealth do you keep in the form of money and how much in bonds, but you have to make a second decision where you choose how much of that money do you keep in the form of currency and how much do you keep in the form of deposits. Theta is the reserve deposit ratio. So it is the fraction of deposits that are kept as reserves. Those are not lent out. Fraction of deposits banks hold as reserves. So second thing that we should just keep in mind over here before we proceed with the problem is, second thing here is, we know that the money supply is given to us as the money multiplier times the monetary base. So the change in the money supply is money multiplier times the change. So we can write this in terms of change in monetary base. We know the money supply is MS. Right, so these are two things to keep in mind. The formula for the money multiplier and how the money supply is equal to the money multiplier times monetary base. Where money multiplier tells us how much dollars of money supply created for each dollar of monetary base. So change in money supply is money multiplier times change in monetary base. Now let's proceed with the question. So for the first part, let's first find the money. So in this question, basically the central bank wants to increase the monetary base by $11,000, right? So we're given the change in monetary base, and you want to find how much does the total money supply change. For this, we'll have to first find the money multiplier. Now, assumptions given in question are, the first is people hold only deposits, so they keep all their money in the form of deposits. So this means C, which was the fraction of your total money demand kept in the form of currency, is 0. Second is if banks don't hold any excess reserves, so theta is equal to 0.1, where if we recall, theta is our reserve deposit ratio. And 0.1 was a required reserve ratio that is imposed by the central bank, because in this case, they're not keeping any excess reserves. The ratio imposed by the central bank. In this case, they're just keeping the reserves set by the central bank and no excess reserves. So money multiplier, we know, is 1 by c plus theta 1 minus c. So it's 1 by 0 plus 0.1, 1 minus 0. So it's 10. So let's just interpret this money multiplier before we proceed forward. How will we interpret this? So interpretation. The idea is that a $1 increase in monetary base will increase money supply by $10. Right? That's how we interpret it. Because the money multiplier tells us how much dollars of money supply can be created from each dollar monetary base. Now let's find the change in money supply or change in money supply. So we know that we can write change in money supply as the money multiplier times the change in monetary base. Right? We can write this now. We know the money multiplier is 10. The change in monetary base is of 11,000 as given in the question. So the change in the money supply is 110,000. It's 10 times more. So it's $110,000. So this was part A. Let's similarly do part B. So now for part B also, we want to find the money multiplier. Now the assumptions given in question, the first assumption is the same. People hold only deposits, right? But the second assumption is different. So let's change that. So for part B, just a sec. Yeah, so part B. So people still hold only deposits C0, but now banks hold 2.5% excess reserves. So theta is now, which is the reserve deposit ratio, is made up of the required reserve 0.1 plus the excess reserve 0.025, because there is a certain amount of reserves that banks are required to hold by the central bank, and they can also keep excess reserves on top of that. In the first example, they weren't keeping any excess reserves, but in this example, they are. So over here, we know theta is the reserve deposit ratio. 0.1 are the required reserve ratio. So these are the required reserves, and 0.025 are the excess reserves, because theta is the fraction of deposits held as total reserves. Some of these can be required, some of these will be required reserves, and some can be excess reserves also if banks hold excess reserves. So this is excess reserves. So now let's change our money multiplier. Let's see what that becomes now. So now we know, oh sorry, so C is still 0, but now theta is different. It's 0.125, 1 minus 0. In this case, the money multiplier is 8. And the interpretation will be similar. For $1 increase in monetary base will now increase overall money supply by $8. Now let's look at for change in money supply. So the only thing that will have to change over here is we'll make this 8. Where we know the change in money supply is the money multiplier, which is 8 now, times the change in monetary base, which we want to still look at is 11,000. So in this case, the change in money supply is going to be 88,000. So now let's look at part C, the last part. In part C, the assumption given in the question, now it's different. Now the first assumption is also true. Here we are going to assume, so in the question now we're assuming that people hold 12.5% of their total money holdings in cash. So C is 12.5% in this case, right? It's no longer 0. In the first two examples, it was 0. So because remember, C tells us how much of your total money demand you keep in the form of cash. In this case, 12.5%. And the second assumption is now still the same as part B, where we're assuming that you have 10% required reserves and 2.5% excess reserves. So now let's see what the money multiplier becomes in this case. In this case, the money multiplier would be, that will take C to be in 0, C will be like 0.125 plus theta 0.125 and 1 minus 0.125. So the money multiplier in this case is 4.27. And interpretation is similar. A $1 increase in monetary base will now increase money supply by 4.27. Now let's look at the change in money supply. Now here the money multiplier we know is going to be 4.27 into 11,000, and that will give us 46933.33. So it's $46,933.33. So the crux of this problem was that we looked at how we can find the money multiplier as 1 by C plus theta 1 minus C, where C is how much of your money demand are you keeping in the form of cash or currency, and theta is a reserve deposit ratio. We looked at three examples. The first case where we calculated the money multiplier was where people were keeping all of their current money, people were not holding any currency, and there were no excess reserves. The second case was again where people were not holding any currency, but you did have banks holding excess reserves. And the third was the most general case where people were holding currency and the banks were holding both excess reserves as well as apart from the required reserves. Right. So this was like the calculation of the money multiplier under three scenarios.